Hi everyone and welcome to another video. So this was a quiz that I conducted in my classes on the chapter of work, energy, power. So this is kind of like a small quiz. I think it's worth 20 marks and this was supposed to be done within 30 minutes. So this is the solution to this quiz. Question number 1. A box of weight W is pulled by a force P along a slope. Length of the slope is D. Box rises a height H. Frictional force is there. Diagram shows the directions of all of these forces and distances. The purpose of this slope is to raise the box vertically, right? So this is basically my output. Which expression gives the efficiency of the slope? So the work which is done by this force P, and the distance it covers in the direction of the force is D. So the input work or the input energy also, because work and energy are the same thing, that's PD. And the output is basically because of the purpose, which is to raise it through some height H. So it raises, work is done against gravity and it covers a distance H in the direction of that force, which is WH. Efficiency is output over input, so WH over PD, which is option D. Question 2. Equation for kinetic energy can be derived using the equations of motion. 4 equations relating to the motion are listed. Which 3 equations can be used to derive the equation for EK? So EK, if you might remember, comes from the idea that kinetic energy gained is equal to work done, which is Fs. Then instead of F we write MAS. And then the third equation of motion, from which we can make AS the subject and substitute it here. So 1, 2 and 3 are used, 4 is not used. So the answer to this is A. Question 3 seems like a tricky question, but it's not really. A ball is projected into the air from horizontal ground and follows the path shown in the diagram. At points Q, R, S, T, ball has such and such kinetic energies. Heights of all of these 4 points are shown. Air resistance is negligible. Which difference in kinetic energies is the smallest? Now obviously we know that there is no air resistance, so all the basically the change in GPE would become the change in kinetic energy, right? So the change in GPE is basically given by mgh. And why am I using this? Because the heights are given. So wherever the difference of heights is the smallest is my answer. Because if the difference of heights is the smallest, the GPE change is the smallest, so obviously the KE change is also the smallest. So the difference between Q and S is 0.1, and I'm pretty sure no distance is as small as this one. S and R is 0.2 meters, T and Q is 0.2 meters, T and R is 0.5 meters. So it's none of these. The smallest distance, which is EQ minus ES, which is option A. Okay, how about this one? Question number 4. A rock of mass 40 kg is released from rest from a height of 20 meters above the surface of the planet. The rocket has a kinetic energy of 32 kilojoules when it hits the surface of the planet. Planet does not have an atmosphere, so no air resistance. What is the weight of the rock on the surface of the planet? So the kinetic energy that it has upon striking the surface was basically the GPE on drop. GPE I know is mgh, and I basically need the weight. So GPE equals mgh here, and I basically need the weight, so I need mg. So the weight would then just be the GPE, which is 32,000, over the height, which is 20, and that turns out to be 1600 newtons. This figure then was just given to confuse you, because you need the weight, so you already need all of mg. So this was of no use to us here. Question number 5. A hydroelectric power station uses the GPE of water to generate electrical energy. In one particular power station, mass of water flowing per unit time is this much. Water flows through a vertical height of this much. Electrical power generated is this much. What is the efficiency? So efficiency, I can see that in this problem is the again ratio of output over input. The output is basically the electrical power generated and the input is the GPE. Now what's given to me is the electrical power, right, which is 100 megawatts. Now this is going to be divided by the power input, but this is GPE. So power input is basically the rate of GPE. So let's say that if I divide this expression by time here and here, this is what I need. And what's been given is basically the rate of mass or the mass flow rate. So this is m over t in itself. So this is 1.5 into 10 to the 5. Everything else goes in as it is into 9.81 into 120. So this thing divided by this entire thing, that's going to be, and after multiplication by 100, that's 57%. Question 6. A car of mass 1100 kg is traveling at constant speed of 15 meters per second up a slope inclined at 10 degrees to the horizontal. Combined frictional forces are directed down the slope and are equal to W by 5, where W is the weight of the car. What is the useful output of the car's engine? So let's say this is the driving force. Let's call this D because this is at constant speed. So the total forces down the slope and the total forces up the slope are supposed to be balanced. So the force down the slope, one of them is the friction, which is W by 5. So 1100 times 9.81, that's W over 5. What else is there? Is the sine component of the weight down the slope, which is mg sine theta. So 1100 times 9.81 times sine 10. Now because of constant speed, this is basically what D would be equal to. So we find D from here and then we multiply by the value of the velocity. So when you do this, this should turn out to be option C. Question 7. In a diagram like this, and we did very similar questions to this in class, drawing a diagram does help. So let's draw a diagram first. So let's draw the slope here. This is the slope, and basically here are your people who are going down this ramp inclined at 40 degrees. So the downward component, because this is also going at a constant velocity, would equal the upward component, which is basically the force that the escalator produces, which is just mg sine theta. So in this way, it's easier than the previous question. So that's going to be the total mass. So 250 people, each has mass 78 times 9.81. This is mg, then sine 40, and this is again the force. So for the power, I would multiply by the velocity, which is 4.3. So now just doing this on my calculator. So this is 528 or 530 kilowatts to 2SF. Now let's go on to the structured question. All right. So question number 1A. Part A, explain what is meant by work done. So work is the product of force and the distance or the displacement. Displacement is just slightly better to write, covered in the direction of the force. Okay, part B, a boy on the board B slides down a slope as shown in 3.1. Angle of the slope is given. Total resistive force acting on B is constant. So the resistive force must be acting up the slope like this. State a word equation that links the work done by the force F on B to the changes in potential and kinetic energy. So as he descends, basically he's going to lose potential energy, and that loss in potential energy will gradually become the change in kinetic energy. But now what will happen is that this energy, it's not all going to go into kinetic energy, because some of the starting energy, which is your GPE, some of it would be used to do work against friction. So you can write it like this, that this plus this is work against friction, or work by friction, because that's the language the examiner uses. Any variant of this equation is also fine. So if you write it like this, that the change in potential energy minus the work done by F equals to the change in KE, that's also fine. If you do change in PE minus the change in KE is equal to the work done by F, that's also fine. Part 2. The boy on board B moves with velocity v down the slope. Variation with time of v is shown in 3.2. So this graph is going on to some weird sort of a value. So let's see what the question is. Total mass of V is given from 0 to 2.5. All right. So we are looking at 2.5. Show the distance moved up the slope is 9.3. So 2.5 is this point. This is the coordinate I'm concerned with. So this is 2.5 here. Now we just need to see the vertical y values. So on the y-axis, each small box is 0.2. So if I'm not wrong, this right in the middle, this is supposed to be 7. Right? So this is 7.2, 7.4. So half into 2.5 into 7.4. Because this is a velocity time graph, so let me also write this on the side. This is good practice to have even before going into the question. Gradient is acceleration, area gives me the displacement or the distance in this case. So half into 7.4 into 2.5 is the area here. So area is distance, which is half into 7.4 into 2.5. So 7.4 divided by 2 into 2.5, which is 9.25. So 9.3 meters to 2SF. All right, next part, the gain in kinetic energy. So gain in kinetic energy is delta EK, for which the expression is half mv square minus u square, right? So half into 75 into the final velocity was what I used, right? 7.4 square minus 0 square, because initially there is no velocity. So I don't even have to write that really. But if there was velocity, I would subtract by the square of that as well. So let's find this value, 75 divided by 2 to 7.4 square, just 2053.5. So I can say 2050 joules to 3SF. Calculate the loss in GPE. So the loss in GPE, again, write down the formula. For a lot of the work energy power questions, you do get marks for writing down the formula. So mg delta H, delta H is the height which it falls through. Now if I think about it, this was the distance moved down the slope, which was 9.3. So 9.3 is basically all of this distance covered, right? I would need this vertical distance. So for this triangle, this is the hypotenuse. This is what I need. Pretty similar to vectors, you can also just see that this is going to be 9.3 sine 30. So mg delta H, m was 75 into 9.81 into the answer which I found, which was actually 9.25 sine 30. A lot of the people, when I was actually walking around and seeing the working that people were doing, I felt that people just do a lot of working before actually thinking about how the question is to be done. And that leads to a lot of mess here and here and here, and they've written something here and they've written something here. If the examiner gets pissed, kids, honestly, he will not bother with your question. So your working needs to be very clear and to the point, and he should immediately see the answer. What I do in cases like this, and this was a practice of mine, is around the final answer, you can draw a box, right? So that always makes it evident to the examiner that what the actual answer is. So this is 3402. So this is 3400 again to 3SF. Calculate the resistive force F. So again, that just comes from my initial equation. So that overall apparently loss in energy, and this is again coming directly from this, that delta PE minus delta KE would be the work done by F. So delta PE was 3400 minus delta KE, which was 2050, is equal to the work done by F, which is F. And as I labeled on the diagram above, F acts to this distance, F acts like this. So the distance it acts to is the answer to my very first calculation part, which is 9.25. So 3400 minus 2050 divided by 9.25. Just take care that because these are already 3SF rounded values, so now I cannot give my answer to 3SF, I must give it to 2SF. So this is 145.9 according to my calculations. To 2SF, this becomes 150 Newton. So that was this quiz, which I think is not very difficult. I did this in 15 minutes along with the entire process of explaining. So I think usually I would have done this in like 10 minutes if I were not explaining. So 3 times that is the time that I gave to the students to try this out. So yeah, this was a moderate level quiz, not very difficult, not very easy either, but it gives you a good picture of where you stand with respect to this chapter. So that's it for this video. In the next one, we'll be looking at more of the work energy power ideas which are related, which are left. And I'll see you in that video then. Bye.